All right, we are on Module 5, Lesson 22, and we are going to be working with equivalent fractions by using visual fraction models and the number line. So we're going to jump down here. Remember, we talked about that fractions and division go hand in hand because when we're finding the whole, so like 0 halves, 0 divided by 2 is 0, but 2 divided by 2 equals 1. 4 divided by 2 equals 2. So those are our wholes. The fractions are equal to the wholes because when they're divided by, it gives you the answer. So we're going to jump down here. Okay, I want you to draw this number line on your whiteboard. So if you don't have your whiteboard or if you need a piece of paper, go get one. And then I want you to, we're going to mark the wholes, right? So let's see if this will work for Mrs. Entz. So 0 thirds is 0, 1/3, 2/3, 3/3 is equal to 1. So then we're going to draw 1. 4/3, 5/3, 6/3 is equal to 2. 7/3, 8/3, 9/3 is equal to 3 wholes, 3 wholes. 10/3, 11/3, 12/3 is equal to 4 wholes. Because 12 divided by 3 equals 4, 9 divided by 3 equals 3, 6 divided by 3 equals 2, and 3 divided by 3 equals 1. Okay, let me get these erased. Okay, so same thing here. Go ahead and erase those, and we're counting by halves this time. We're going to mark our wholes. So go ahead and pause me if you need to rewrite, whatever. And so here we go. 0 halves, 1 halves, 1 half. 2 halves is equal to 1. 3 halves, I'm going to mark these first. So 4 halves is equal to 2. 2, 5 halves, 6 halves is equal to 3, 7 halves, 8 halves is equal to 4, 9 halves, 10 halves is equal to 5, 11 halves, 12 halves is equal to 6. Okay, so 4 divided by 2 equals 2. 6 divided by 2 equals 3. 8 divided by 2 equals 4. 10 divided by 2 equals 5. And 12 divided by 2 equals 6. All right. So this is when we're, if you notice that the even numbers, let me mark 0. The even numbers are what make the whole numbers. So 3 halves is not equal to a whole because 3 is odd and 2 is an even number. But 2 halves is equal to 1. 4 halves is equal to 2, so on and so forth. And that's always going to be true with halves. All right, guys. So let's get this erased. You can go ahead and erase your wholes and draw your number line again. Hold on. Okay, now we're counting by fours. So again, let's go through and mark the wholes. So go ahead and pause me. You can draw this number line, and then we're going to come up here. So this would be 0 right here. 1, 2, 3, 4 fourths is equal to 1. 5, 6, 7, 8 fourths is equal to 2. So if you look here, 1, 2, 3, the fourth line. 1, 2, 3, 4. 12 fourths is equal to 3. And you can go back and look. 12 divided by 4 equals 3. So on and so forth. Okay, guys, I hope that this is clicking in your brain and it's making sense to you. Okay, let's keep going. Okay, so now we're going to move on to our application problem. So remember, we're going to read the problem, we're going to find out the important information, and then we're going to write it down. So here is our application problem. Mr. Ramos wants to nail the TV cord against the wall so no one trips. He puts 7 nails in equally spaced along the cord. Draw a number line representing the cord. Label it from 0 at the start of the cord to 1 at the end. Mark where Mr. Ramos puts each nail with a fraction. Whoops. So he starts at 0. Hold on. He starts at 0 nails, but he would put a nail here. So that we would mark that. So instead of being 7, counting by sevenths, we're actually counting by 6 because we need to account for this first nail because it says that we started at 0 at the start of the cord to 1 at the end because we only have one cord, right? So it would be 0, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. Okay, so let's look at how they did it. Okay, then it says to build a number bond with unit fractions to one whole. So our whole is equal to 1, and our unit fractions is equal to 6 of 1/6. So see 1, 2, 3, 4, 5, 6. And that equals our whole. All right. So write the fraction of the nail that is equivalent to half of the cord. So where would it be halfway? Well, if we look at this number line, we can see, so you would go halfway and meet in the middle. And I can tell by looking at this that if I start here, there and 0 and 1, there's 2 numbers in between both of them. And so 3, 6 is equal to halfway. Well, let's think about this for a minute. Can we divide 3, 6 and make it smaller? We can, because 3 goes into itself 1 time and 3 goes into 6 2 times. So it would be equal to 1/2. Okay, let's see what they have next for us. Okay, remember that, so the fraction that was equal to 1/3 Okay, so I don't know if you have your strips that we made from the other day or not, but let's name a fraction that is equal to 1/3. Hold on, let me draw them for you. Okay, so here I have 1/3 on top, right? So 1 box up here, and we have 3 boxes. Down here I've done 6. So I'm going to do 2 of those because 6 is twice as big as 3, and 2 is twice as many as 1. So an equivalent fraction to 1/3 would be 2/6. Now let's look at halves. So I'm going to draw 2/4. Hold on, I gotta draw 2 boxes that are exactly the same so you guys can see the that they are the same. And okay, I got this. Okay, so if you look up here, I have 2/4, and down here, sorry, I have 1 box that's cut into 4s, and then underneath it, I have another box that's cut into 8s, because 8 is twice as much, it's twice as big as 4. So I will do 2/4, and then if you can see this, so we're pretending that these are perfectly even and the lines line up perfectly. And if they do. So you can see that 2/4 is equal to 4/8 because you've got 4 left over here and 2 left over here. So 1/2 is equal to 2/4 and 4/8. Okay, remember how I said it had to be even numbers to be equal to 1/2 when we were counting by halves? This shows that. All right, okay, let's look at some models. So 1/3, 2/6, and 3/9. These 3 wholes are the same. Need to name the shaded fraction as 1 point to the model. Are these fractions equivalent? Are they equal? Well, let's look at them. So let's see. What do you think? Are they equal? If you were to put these, they're all 3 exactly the same size. So would they be equivalent? Well, so let's go back to the division piece of this. 1/3. Well, what number? Let's see. 6 divided by 2 equals 3. So 2 will go into itself 1 time. So let me show you guys equivalent fraction. 2/6. 2 will go into 2 1 time, right? If we take, and then 2 will go into 6. How many 2s are in 6? 2, 4, 6, 3. So is that equivalent? Is 2/6 equal to 1/3? Yes. Okay. How about 3/9 and 1/3? Well, 3 can go into 3 1 time. So, no, 3/9. And 3 can go into 9 3 times because 3, 6, 9. So is 3/9 equal to 1/3? Yes. So they are all equivalent. They're equal. They take up the same amount of space. Even though there's different pieces, they still take up the same amount of space. So thinking about the pieces to the whole, and if the holes are the same size, how many different ways can they be equal to each other? Okay. Okay, so we are moving on to the problem set. It says, write the shaded fraction of each figure on the blank, then draw a line to match the equivalent fraction. All right, so, oh, gotcha. I got it now. Okay, so we are going to, I'm going to use this purple color. So here we have 1/2, right? Over here we have 2/3. Right here we have 1, 2, 3, 4, 6. Over here we have 1/3. Let me, oh shoot. Okay, so, all right, I'm awesome. Okay, right here we have 3/4. And then right here we have 2/4. Okay, so let's look at these for just 1 second. I can tell by looking at the shaded part of 2/4 and 1/2 that they go together. So I'm going to put those two together. Now, let's look at 2/3 and 4/6. Now, if this was moved over, and would that take up the same amount as this? Yes, they're just separated, but the pieces are still the same. So if I were to draw a line like this and turn that into 6, it looks exactly the same as 4/6. So I can concur that 4/6 is equal to 2/3. Now I need to erase so that I can match up some other equivalents. Hold on. Okay, I got them all on the same page. Yay. So let me quickly do the ones that we've already identified. Hold on. Okay, so, and also on 2/3 and 4/6, if you're not sure, what number times 2 equals 4? Well, 2. What number times 2 equals 3? Or what number times 2 equals 6? It's 3. So that shows that they're equivalent. All right, let's look here. We have 3/4. I could just use the line. 3, 6/9, 3/9. And then this one's a little bit tricky. So 1, 2, 3, 2, 4, 6, 8. And we have 2, 4, 6, 6/8. Okay. Yeah. Okay. So 1/3, how many times, what number times 1 equals, hold on, let me look at this for just 1 second. Okay, so 3/4 and 6/8. Well, 6 is exactly twice as many as 3, and 4 is twice as many as 8. So they would be equivalent. Then let's look at 1/3 and 3/9. 3, woo, that's right. I don't know how that happened, but sorry, 3 times 1 is 3. 3 times 3 is 9. So 3/9 and 1/3 are equivalent. All right, you guys, and then you need to do, so I did the first page of the problem set with you. You need to go on, do the exit ticket, and then make sure you get done with lesson 22 today. Bye.